Historically, when we talk about software, we talk about it like a tool.
Right.
It's like a hammer. You buy a hammer, you pick it up, you swing it, and, well, it hits the nail.
Yeah, and if the nail bends, that's on you.
Exactly. The human is the operator, and the software is just this dumb lever. But looking at the tech landscape right now, I mean, it feels like that hammer just woke up, looked at the blueprints, ordered its own nails, and, started framing the house while we were asleep.
It really is the absolute definition of a paradigm shift.
Yeah.
I mean, we are officially moving from building static tools to orchestrating autonomous governed systems.
Yeah.
The software is it's no longer waiting for your input to take the next logical step.
And exploring that shift is exactly our mission for this deep dive. Today, we're looking at a highly curated stack of insights straight from the desk of tech analyst Andrew Kagan.
Specifically, his newsletter from May 29, 2026.
Right. So if you want random technical news you can actually use, this is pretty much the ultimate snapshot. And a very clear narrative emerges from these 8 focus areas he covers, which is basically that the foundational layers of the internet are being rewired for autonomous agents.
They absolutely are.
So let's skip the preamble and start right at the bedrock of where these systems live, which is Azure infrastructure. We're pulling from John Saville's May 22nd Azure update here.
Yeah, and the underlying theme here really seems to be forcing modernization while minimizing the blast radius of those changes.
Which is always the tricky part.
Oh, totally. The security debt cleanup is getting really aggressive.
Yeah.
Microsoft is officially retiring TLS 1.0 and 1.1 by May 2027.
Wow, okay.
Yeah. Applications are going to be forced onto version 1.2 or higher. So for any of those legacy systems clinging to outdated cryptographic protocols, I mean, the clock is ticking very loudly.
Which is going to cause some serious heartburn for enterprise admins with, hard-coded dependencies.
Oh, massive heartburn. But they are balancing that strictness with some incredible safety nets for modern network management. Like, Network Watcher just introduced a new rule impact analyzer.
Okay, how does that work?
So if you are tweaking your network security groups, your NSGs, you can now simulate how those changes will affect live traffic before you ever actually hit apply.
Oh, that's huge. So you get to see the blast radius of a bad firewall rule without actually bringing down your production environment.
Exactly. And that ability to simulate impact is crucial because the environments themselves are just becoming hyper-specialized.
Right.
Take the OS layer. Azure Linux 4.0 just dropped, and we are seeing a major architectural fork. Historically, Azure Linux was based on CVL Mariner, which is a lightweight OS primarily used for containers.
But they split it in 4.0, right?
They did. With 4.0, Microsoft split the development track. The version for virtual machines and the Windows subsystem for Linux is now derived from Fedora.
And the container side, Azure Container Linux, which is now generally available, that's based on the Immutable Flatcar project.
Yep, that's the one.
Let's dig into the functional benefit there, because using an immutable operating system for containers makes perfect sense. I mean, you don't want configuration drift on a container host.
No, not at all.
By locking down the file system so it literally cannot be changed after boot, you drastically reduce the attack surface.
While your traditional VMs still get the flexibility they need from that Fedora derivative. So it's really about fitting the architecture to this specific workload.
Makes sense.
But the update that really changes the daily reality for engineers is the Azure SRE agent.
The Site Reliability Engineering Agent.
Right. It is now available in the Azure Model Context Protocol Server, or MCP.
Let me just paint a picture for you listening, because this is wild. Imagine you have a veteran sysadmin who knows the entire history of your incidents and the exact topology of your architecture.
A unicorn employee, basically.
Exactly. Now, instead of opening a browser tab, navigating the Azure portal, and, digging through metrics, that sysadmin is just sitting seamlessly inside your code editor. You open your GitHub Copilot CLI or VS Code, and you just ask a question in plain English. You never have to break your flow state.
And meeting developers where they already work fundamentally changes the speed of iteration. Infrastructure is no longer this destination you have to visit. It is a context-aware assistant embedded directly into your coding environment.
So if infrastructure agents are now sitting right next to you in VS Code, that completely alters your daily rhythm. The bottleneck isn't provisioning servers anymore.
No, not at all.
It's the actual writing and reviewing of the code itself. Which brings us to the DevOps and SRE focus area. Let's look at the Visual Studio May update.
Yeah, the focus there is heavily on this plan, review, refine rhythm. They've introduced a new plan agent that lets a developer sort of sketch out an entire architectural approach with the AI before a single line of code is ever generated.
That planning phase is so critical now because Copilot isn't just tweaking a single Python script anymore, right?
Exactly. It is making sweeping, coordinated changes across your entire architecture simultaneously.
Which is terrifying.
It is.
Yeah.
Reviewing those files one by one natively in an editor is exhausting, and you totally lose context. So Visual Studio introduced the multi-file summary diff, which aggregates that entire wave of changes into a single, unified view.
I do have to push back on the mechanics of that, though. I mean, if Copilot is editing 5, 10, or 20 files at once across different services, doesn't a single summary diff risk creating a massive blind spot?
It definitely can.
It just feels like we are inviting developers to skim a summary and blindly approve bad code across their entire architecture.
That is the exact failure mode the industry is terrified of. And it's why the tools around these agents are evolving to isolate risk.
Right.
You cannot trust the agent implicitly.
Which brings us to the WebAssembly updates for AI agents that Kagan highlighted.
Oh yeah, WebAssembly acts as this universal, highly secure sandbox. It gives us runtime portability across languages like Python, JavaScript, Kotlin, and Swift.
Right, so an AI agent can pull down components and run them locally from the command line interface. And the brilliance of utilizing WebAssembly here is that the AI agent doesn't even need to understand WebAssembly beforehand, right?
Exactly. The architecture provides a safe, isolated execution environment that completely restricts host access.
So if the agent writes complex multi-file logic, it can execute and verify that code inside a sandbox that physically cannot touch the broader system unless it's explicitly permitted.
Yep. So we've got the infrastructure, and we've got the smart sandboxed dev tools. But an AI system is essentially just an engine.
Right. It is only as capable as the data fueling it.
And if your data layer is slow or unoptimized, your AI is going to be slow and, frankly, wildly expensive.
Oh, absolutely. The compute cost of querying unoptimized data is just astronomical when you scale up to enterprise AI. And this brings us to the data and AI focus area. This is where Microsoft Fabric's new incremental liquid clustering changes the math.
It really does.
Imagine you're managing a massive data lake. With standard clustering algorithms, it feels like owning a huge library where every time you buy one single new book, you have to take every single book off the shelves and reorganize the entire building.
So inefficient.
Right.
Yeah.
You are paying the compute cost to rewrite entire 100 gigabyte groups of Parquet files just to append one tiny kilobyte of new data.
The inefficiency is staggering. Incremental liquid clustering solves this by simply skipping the already clustered files entirely.
So it only targets unclustered data, small files, or deleted files.
Exactly. It just places the new data in the optimal spot without rewriting the historical archive. And it includes an auto-reclustering feature to handle overlapping data invisibly in the background.
The performance metrics on this are wild, by the way. It's up to 8.9 times faster for streaming data ingestion.
Wow.
And 4.9 times faster for your standard ETL pipelines. And the cascading business impact of those cost savings is massive because it frees up your compute budget for the actual AI reasoning.
Absolutely. We're also seeing that intelligence get pushed closer to the data itself.
Right.
Like Cosmos DB integrating LangChain and LangGraph for vector and hybrid search natively in Python.
But when you have that much optimized data, you need like an intelligent traffic cop to manage how the AI interacts with it, right?
You do, and the updates to the AI Foundry Model Router do exactly that. It basically evaluates every incoming prompt and dynamically routes it to the most appropriate model out of 28 different options.
Oh, I see. So if a user asks a really simple data retrieval question, the router just sends it to a fast, cheap model.
Exactly. But if the prompt requires complex analytical reasoning, it routes it to something heavy like GPT-4 or Claude Opus.
So it automatically balances performance, response quality, and token spend behind the scenes.
Yeah, it's entirely seamless. So with the data perfectly clustered and the prompts dynamically routed, the next logical question is how we surface all this intelligence to the actual business users.
Right, the orchestration layer, which takes us to the Power Platform and Dynamics 365.
Yep. And the major milestone here from Copilot Studio is that computer-using agents are now generally available.
Okay, so this allows agents to interact directly with websites and desktop user interfaces when legacy systems simply don't have APIs available.
Exactly.
But wait, robotic process automation or screen scraping has historically been the most brittle technology on the planet.
Oh, a nightmare.
Right. If a vendor updates their software and moves the submit button 2 pixels to the left, The whole automated workflow shatters. Are we just reinventing a broken wheel here?
I get why you'd think that, but the underlying mechanism is completely different now. Traditional RPA relied on deterministic scripts. It was hard-coded to click specific X and Y coordinates or look for a specific HTML tag.
Right, which breaks constantly.
Exactly. Computer-using AI agents don't do that. They utilize computer vision to build a semantic understanding of the screen. They actually reason over the UI. Yeah. So if a button moves or the entire layout changes, the agent adapts natively because it understands the goal of the task, not just the coordinates. It turns a historically fragile process into a highly resilient system.
And these agents aren't just talking to legacy interfaces anymore, they are talking to each other. Agent-to-agent, or A2A communication, is also generally available now.
Which is huge. Agents can now intelligently delegate subtasks to other specialized agents.
And we should probably also highlight the expansion of available models in Copilot Studio. Mistral Medium 3.5 is now an option.
Yeah, which is a massive win for organizations in the European Union. It provides high-tier reasoning capabilities while allowing them to actually meet strict regional data sovereignty and processing requirements.
That makes a lot of sense. And that orchestration capability is trickling down to everyday knowledge workers, too, fundamentally changing collaboration in Microsoft 365.
It really is.
We are seeing a new feature called Copilot Notebooks rolling out.
Yeah, the May 2026 update.
Right. It operates as a shared AI-powered workspace that syncs across the main Microsoft 365 app and OneNote. So users can drag in context from incredibly diverse sources like SharePoint presentations, Teams conversation threads, email chains, and the AI reasons over all of it in one unified collaborative space.
And for developers building custom AI tools for their specific business needs, they've introduced the proxy agent pattern via the M365 Agent Toolkit.
What does that solve exactly?
Well, it allows you to securely connect a custom-built AI back into the M365 Copilot ecosystem without passing raw security secrets or API keys back and forth. It's a huge security improvement.
That is huge. But, centralizing all this cross-departmental data into AI notebooks creates a kind of terrifying security dynamic.
Oh, definitely.
We have to talk about the dreaded everyone except external users permission link.
Oh, no!
Right. For a decade, people have shared SharePoint documents with their entire organization just because it was easier than actually managing permissions.
Yeah, security through obscurity used to protect that data.
Yeah.
I mean, a human wasn't going to spend 3 weeks digging through thousands of SharePoint sites to find a sensitive HR document from 2019.
But an AI agent can retrieve and summarize that forgotten document in 3 seconds.
Yep.
When you introduce AI, security through obscurity instantly evaporates.
Completely. And that is exactly why Microsoft just introduced a tenant setting to enforce strict expiration dates on people in your organization sharing links.
It forces hygiene on the data layer.
Exactly. And that data hygiene is the perfect bridge into the most critical challenge of this entire shift: security, compliance, and privacy.
Yeah, you cannot have autonomous computer-using agents executing tasks across your tenant without an ironclad governance framework.
You really can't. And the open source community is stepping up here with the Agent Governance Toolkit on GitHub. It specifically targets the OSP agentic top 10 vulnerabilities.
Because there is a huge misconception right now that you can just put instructions in your system, prompt telling the AI not to do anything malicious.
Oh yeah, that doesn't work.
Relying on prompt layer defenses is literally like asking a toddler nicely not to eat a cookie. They might listen once, but eventually the temptation wins.
That is a perfect analogy. The OWASP Pro framework is very clear that prompt injection cannot be fully prevented at the model layer. A prompt is ultimately just a polite request to a statistical system.
Right.
So the Agent Governance Toolkit completely abandons the idea of asking nicely. Instead, it enforces execution sandboxing with 4 distinct privilege rings combined with tamper-evident audit logs.
So taking the toddler analogy further, it's like putting the cookies in a timed biometric safe.
Yes.
It doesn't matter what the toddler wants or how cleverly they ask, the system physically lacks the privilege to execute the action.
Exactly. And we're also seeing the infrastructure itself adapt to house these agents securely. Like Windows 365 for Agents now provides a secure, fully auditable cloud PC execution environment specifically dedicated to your AI.
Oh, that's smart.
Yeah. And on the endpoint management side, Copilot in Intune is giving human administrators KQL Custo query language assistance and skill-based prompts to manage these really complex environments.
The defenses absolutely have to evolve because the threat landscape is just exploiting legacy infrastructure to devastating effect. Kagan's newsletter highlighted a multi-stage Linux intrusion that is a textbook example of lateral movement.
Oh, I read about that one.
Yeah, attackers breached an exposed F5 BIGIP edge appliance. From there, they established a foothold and systematically pivoted internally until they compromised a Confluent server, which allowed them to siphon off highly sensitive credentials.
And the monetization of these breaches is shifting too. There was a fascinating breakdown of a cryptojacking campaign abusing Screen Connect.
How are they doing that?
Attackers utilizing SEO poisoning, basically manipulating search engine results, and even AI chatbot responses to surface malicious troubleshooting sites.
Wow.
Yeah, and once a user downloads the payload, the attackers take over high-performance PCs, specifically to hijack their GPUs for cryptocurrency mining.
That is wild.
Hmm.
You know, when we talk about defending against these lateral movements, the default answer is always zero trust. But the Cloud Security Alliance Zero Trust Workgroup shared some really brilliant nuance regarding operational technology, or OT, and IoT networks.
Right, because OT is different.
Exactly. In a traditional IT environment, confidentiality is the supreme goal. You lock everything down.
But in an operational technology environment, think of a power grid, a water treatment plant, or an assembly line, the primary incentive is uptime.
Right. Surviving a tornado or a hardware failure is frankly more important than data privacy.
Exactly. If you apply aggressive IT-style zero trust to a power plant, you risk accidentally shutting down critical infrastructure during a false positive.
Which is catastrophic.
Right. It requires highly customized microsegmentation strategies that actually respect the physics of the machinery.
So with security paradigms, infrastructure code, and AI capabilities shifting this rapidly, how is a human developer supposed to absorb all of this? I mean, the learning curve feels entirely vertical right now.
It does. And the answer, ironically, is using AI to learn about AI.
Yeah, we're in the learning and certifications area now. Microsoft open-sourced a tool called the AI Engineering Coach to help developers build better agentic systems.
But the concept I found most illuminating there was from John Saville's breakdown of understanding AI skills.
Yes. His explanation of progressive disclosure is probably one of the best frameworks for understanding token management in large language models.
I completely agree.
He used this incredibly practical analogy of cutting down a tree. If you are a lumberjack, you don't carry a heavy 500-page chainsaw maintenance manual in your backpack all day just in case you need it.
Right, that just weighs you down.
Exactly. Instead, you have a simple one-page catalog pinned to the door of your tool shed. It just lists the names and brief descriptions of the tools available to you. Only when you explicitly decide that you need to cut down a massive oak tree do you walk into the shed and grab the heavy manual.
Translated to AI architecture, that initial catalog is the system prompt. You only feed the large language model the names and short descriptions of the tools it can use.
Which consumes maybe, what, 100 tokens?
Exactly. It keeps the model's attention mechanism highly focused and costs fractions of a cent. Only when the LLM dynamically decides it needs to execute a specific skill does the system fetch the full, detailed API instructions.
Which might be 5,000 tokens long.
Right. It prevents the model from hallucinating by overloading its context window with irrelevant instructions, and it drastically cuts inference costs.
It's just such an elegant architectural pattern. Well, let's zoom out for our final focus area, industry news and trends. We spent a lot of time in the Microsoft ecosystem, but the rest of the industry is in an absolute arms race to build the infrastructure for these autonomous agents.
It's a land grab right now.
Look at Anthropic. They just dropped $300 million to acquire a startup called Stainless.
And the strategic value of that acquisition is entirely about supply chain dominance.
Really? How
Yeah.
so?
Well, Stainless built highly efficient shared SDK generators that were heavily relied upon by Anthropic's primary competitors, including OpenAI and Google.
Oh, wow.
Yeah. By acquiring Stainless, Anthropic essentially bought a critical piece of their rival's developer tooling and shut down public access. It is a massive, aggressive land grab for developer mindshare.
And competition is scrambling to adapt. Over in the open source community, a project called OpenClaw just passed 300,000 stars on GitHub, which indicates a massive developer appetite for self-hosted, highly controllable AI agents.
And Google immediately countered that momentum by launching Gemini Spark, which they're positioning as a 247 managed cloud agent.
So it is the classic tech battle, the convenience of a fully managed cloud service versus the privacy and control of a self-hosted open source solution.
Exactly. But the architectural update that truly redefines the landscape came from Cloudflare. They have officially completed a comprehensive 6-layer agent infrastructure stack.
Six.
Yeah. It includes dynamic workers that can boot and execute code in milliseconds, and dedicated agent memory systems that can extract, store, and retrieve structured context over long periods of time.
But the top layer of that stack is the one that really changes everything. They introduced a commerce layer, co-designed directly with Stripe.
Yeah, that is mind-blowing.
Cloudflare has built a protocol that allows AI agents to autonomously create accounts, purchase web domains, and deploy code to production.
You could basically give an AI agent a $100 a month spending cap, assign it a business objective, and just let it go to work on the open internet.
We also saw a brief nod to the hardware side, with quantum machines reaching a new performance milestone on Rigetti quantum hardware, suggesting the compute layer is preparing for even more complex workloads.
Synthesizing all of these industry moves, particularly that Cloudflare and Stripe integration, reveals a really profound shift. We are witnessing the real-time construction of a parallel internet architecture. It is an internet optimized not for humans clicking links in a web browser, but specifically engineered for AI agents to browse, compute, provision infrastructure, and transact money entirely autonomously.
Which brings our deep dive full circle today. We started at the bedrock of Azure infrastructure enforcing security updates. We watched that infrastructure move into the developer's code editor.
Yep.
We explored how Fabric's liquid clustering provides the optimized data to fuel those tools, and how Power Platform orchestrates those insights into resilient business actions.
We saw the critical need for strict data expiry in Microsoft 365, which leads to the necessity of rigid, ring-fenced agent governance.
And finally, we looked at how the broader industry is building the financial and compute rails for these agents to operate independently.
The interconnected nature of these updates is really why keeping a pulse on Kagan's insights is so valuable.
Definitely.
Whether you are writing the code, securing the tenant, or defining the business strategy, understanding this transition from static tools to autonomous agentic systems is the ultimate competitive advantage right now.
It really is the difference between swinging the hammer yourself and managing an autonomous construction crew. Which leaves us with one final thought for you to ponder today. We just discussed Cloudflare giving AI agents their own Stripe accounts with actual spending limits.
Yeah.
And earlier, we looked at Windows 365 provisioning dedicated secure cloud PCs exclusively for agents to execute tasks.
They are basically accumulating the trappings of human workers. They have their own operational budgets, their own dedicated computing hardware, and their own software development workflows.
Right. So if an AI agent has its own corporate bank account, its own desktop computer, and its own performance metrics, at what point do we stop treating these agents as software features to be patched by IT and start treating them as digital employees that require their own HR policies, performance reviews, and offboarding procedures?
It is definitely a wild thing to think about.
Something to mull over as your tools continue to wake up. Thanks for joining us on this deep dive.